All right, so we were talking about the InSight lander. It's this. It doesn't. It's actually stopped working. I think that was about. What was it? About a year ago. Maybe 6 months ago, something like that. It gave its last signal, but it did last for a few years and gave us lots of information. It helps us understand the interior of Mars. So remember, the thing about Earth is it has a liquid outer core, and that's what causes. So this it's called the dynamo effect. It's the fact that the liquid outer core is rotating at a different rate than the surface of the Earth, causes the Earth to have a magnetic field. That's not the case with Mars. Even though like this might be slightly molten, it's not rotating at a different, not rotating differently enough to cause an overall magnetic field. We think that there was once a magnetic field on Earth, on Mars, and in fact it's frozen into some of the rocks. Like in other words, the iron lines up in certain directions, but there's no overall magnetic field when we're in orbit around Mars. We don't detect a magnetic field from an overall magnetic field from Mars. All right. Let's see. Having a mass between dead Mercury and Earth, Earth and Venus, of course, have the same. Mars should have an roughly intermediate tectonic activity. And of course, we do see some evidence in the past of that. In fact, Olympus Mons looks relatively young, like young being, hundreds and hundreds of millions of years old. But that's not that, it's not a feature that's billions of years old. And we can tell that because we don't see the cratering near Olympus Mons. And so, that tells us that this was a relatively new feature on Mars. All right, and it doesn't seem to be volcanic activity on Mars, but that doesn't mean maybe in the the last few 100 million years, that probably is what there was volcanic activity that created Olympus Mons and possibly Valles Marineris. All right. So Mars does have two moons, as a matter of fact. Yeah, let me just let me back up just a little bit. I think this is just an interesting little thing. All right. So you remember Johann Kepler, right? You certainly had, you learned about Kepler's laws in lab. If you haven't already had those labs, so Kepler, who lived 400 years ago, actually predicted. Now, he didn't have any evidence at all for this, right? So he had no way of knowing this. He predicted that Mars would have two moons, and here was his reasoning, right? The Earth has one. At the time, he lived during the time of Galileo, so he knew that Galileo had discovered four moons, right? And so he thought that there was some kind of progression, some mathematical progression where the Earth had one. Like he always looked for some kind of mathematical significance to things in the solar system. And so he said, the Earth has one moon, Jupiter has four, so he thought that Mars must have two. And it turns out he was right, but for the completely wrong reasons, right? Mars does have two moons. They're really tiny. There's Phobos is the larger one, and Deimos. Deimos is actually getting a little further from Mars as time goes on, and Phobos is getting closer to Mars. In fact, we think Phobos will eventually burn up in the Martian atmosphere. Perhaps millions and millions of years into the future, Phobos won't be there anymore. Deimos, we think, was perhaps a captured asteroid, and Phobos might have been the result of some large collision with Mars. Some large object hit Mars, and some of Mars, vaporizes, right? So, physical pieces of Mars vaporized, and then were flung out into the outside of Mars, and coalesced into this moon that we call Phobos. All right, so it's kind of interesting. The two of them orbit right at the equator of Mars, and what else? They both have really low densities, as it says here. And like I said, this Deimos seems to be a captured asteroid. Keep in mind, like the asteroid belt, and we haven't quite gotten to that yet, but between Mars and Jupiter is what's called the main asteroid belt. There are literally thousands upon thousands of these little, tiny objects that didn't go into planet formation, or perhaps, these things were the result of collisions with planets, and they collected in the solar system between Mars and Jupiter because of the mass of Jupiter, right? The gravitational attraction of Jupiter puts them in this very stable orbit between Mars and Jupiter. All right, so what else about these moons? Yeah, that's So I mean, they've been studied. We actually knew about them long before we ever sent any spacecraft. I think they were discovered over 100 years ago. Yeah, I mean they were kind of tiny. Deimos is more of a potato-shaped looking thing, and all that means what the asteroids, they're just, most of them are not large enough to self-gravitate into a sphere. I mean, they're almost spherical, but they get these lumpy potato-looking shapes. All right. Anyhow, so that's the all right. So now what we're going to do is we're going to compare the terrestrial planets, at the same time. So and we're going to include, in some cases, we'll include the moon. Remember, the moon and Mercury are very similar. At least the fact that neither of them have an atmosphere. They're not that much different in size. Of course, Mercury is a little bit bigger. But Mercury, even though Mercury is considered a planet, there are actually moons that are bigger than Mercury, right? And we're going to find out about those when we turn to Jupiter. All right, so let's look at the. You remember, these are like the average temperatures. Okay, so all right, so like on the surface of Mercury. It can be, between daytime and nighttime. It varies greatly, right? Between 7. So this is in Kelvin, 700 Kelvin, more than that, and down to 80 Kelvin, right? So, this is an incredible difference in temperature. Right. So you think about it in Fahrenheit. In Fahrenheit, so this first number is the average of the two. Okay. All right. So because it doesn't have an atmosphere, it gets really, really cold at night, and really hot during the day. Because it's so close to the sun, and it gets an incredible amount of sunlight. All right, so then we turn to Venus. Of course, Venus is basically Earth's twin. Notice, there's its diameter in kilometers. So diameter now, we're not, usually we talk about the radius, but the diameter is more than 1,200 kilometers. So, Earth is closer to 1,300, a little less than 1,300, but they're basically the same size. They have vastly different atmospheres. Uh, Venus's atmosphere is 90 times the atmospheric pressure on the Earth. There are clouds of sulfuric acid on Venus. The clouds are so thick that you can't actually see. In other words, visible light does not penetrate, Venus. We need radar to be able to actually form images. The temperature, it doesn't vary all that much. There's a 50-degree swing between when the sun is directly overhead and nighttime, because of course the atmosphere being so thick and made mostly of carbon dioxide, it holds on to almost all the heat that comes in. And so, the average temperature is about, in Fahrenheit, is about 880, almost close to 900 degrees Fahrenheit, right? That's like having way hotter than having your oven on broil, right? It's like almost twice that temperature. Okay. The Earth, it has a nice moderate temperature. It varies. At the poles, of course, it gets really cold, but the average temperature is close to 60 degrees Fahrenheit. So of course, it because of the pressure on the Earth and its nice roughly 60 degrees temperature, you have liquid water that can exist on the surface. You have rain that occurs, clouds of H2O. It's a nice place to live, right? It's a very nice place, and of course, of all the terrestrial planets, it is the largest, right? It's the largest terrestrial planet. It has its own magnetic field, which protects the Earth, protects its atmosphere. The moon is a relatively large object. Notice it's slightly smaller than Mercury, but it's actually pretty big. The Earth Moon system, actually, the moon is the largest moon, not in the solar system, but it's the largest moon compared to its host planet, right? So there are larger moons than our moon, but they're going around Jupiter and Saturn, right? Which are really, really big compared to the Earth. All right, so the moon has no atmosphere. Its temperature varies greatly. It's the huge swings in temperature. So the average temperature is negative 80 degrees Fahrenheit, so it's well below zero. It's because there's no atmosphere. Let's see what else. There's craters. The moon once had a little bit of geological activity in its very early stages. It was the result, of course, of something crashing into the Earth, and then that material vaporized and went into orbit around the Earth, and then coalesced into what is our moon. And then, of course, there's Mars. Mars has this size that's between Earth and Mercury. It has a very thin atmosphere, only 1% the atmospheric pressure that the Earth has. Its atmosphere is made of carbon dioxide mostly. There's some nitrogen. The temperature varies greatly because the atmosphere is so thin, and it's pretty cold. I mean, generally, it's pretty cold on Mars. It hardly ever gets very warm. It's not a good place for vacations.